Welcome to my presentation. My name is Vaibhab Chakraborty and my USN is 1VE19CA028, and today I'm going to give a presentation of 5G RAN architecture. We have come across the name 5G a lot of times in our life, as since this October itself in India launched on 21st October, India launched 5G services for publics to use, and since then we have seen a lot of revolution in the 5G department. So we need to talk the need for 5G. So, with growing mobile data traffic is rising rapidly, mostly due to video streaming. Today, everything is in format of video. Everything that we see in some format or the other take context of some video. So that's why we can say that there's a huge influx of video technologies and data traffic. With multiple devices, each user has a growing number of connections. Each person has multiple devices right now. Each person has to be taken in context with a lot of other devices. For example, a person has a work phone, a person has a personal SIM card, a person has SIM card, one for family, one for friends. With each context, like the number of growing connections keeps increasing exponentially. Internet of Things will require networks that must handle billion or more devices. We keep that IoT boom keeps happening, and this IoT boom will process the growing number of devices that are occurring every day. With the growth number of mobiles and increased data traffic, both mobile and networks need to increase energy efficiency. Energy efficiency means the conserving of energy and being more efficient running on energy. So when we talk about that we can see uh, here we see that all the forms of various forms of technologies that have already been used. So since the 1980s, we had 1G, which was analog. There were voice only, limited coverage and mobility. For example, AMPS. So there was only voice, like for example, we could talk to someone on the phone. We could call someone landline. Like these were the examples of 1G technology. From 2G, we started getting digital. So improved voice, security, like nobody could tap your messages that you are sent, and data SMS messages for which was included by the technologies such as GSM and CDMA. In 3G came the advance of mobile data, good data rates, smartphones, and better voice. So from here we can see the basic technology boom happening, which was around 2000 to 2010. Like from here, everything expanded exponentially. And 4G came in late 2016 to 2017, where we have mobile broadband, high data nets, LTE softwares, and everything. This provided a huge boom in that sector of data. And we know that the one of the first LTE providers in India was Jio. So Jio provided the necessary boom in network that was supported by LTE. And 5G, as we know, is it will provide us the connection of IoT. So EMBB, MMTC, and URLLC are high-speed, ultra-reliable, and low latency, high connection density devices. So what does 5G aim to do is connect every single data. 4G, aim of 4G was to have high-speed data, and aim of 5G is not just to have high-speed data, but to connect every single item in a way or other. Like for example, every single device at your home, electronic device, can be connected to one another using a Wi-Fi network. So that is what 5G is aiming to do. So this is the boom that we keep talking about. So heterogeneity of use cases. What are the 5G use cases that are being used right now? So generally, in most cases, we can see that there are three ways a 5G network can be used. Extreme mobile broadband, which is like extremely high speed network that can be used having multiple gigabits per second technology, so that people in major may be using that. And then we can have massive machine communication, like people talking to machine, one machine talking to another, and it can be scaled out to a huge extent. And the third part use case that is used is critical machine communication, which is basically the concept of a machine communication being intensely high level, like it can perform intense complexity of communications or operations. Massive machine communication and critical machine communication, the difference being massive will be able to communicate a lot of requests at the same time, and critical will be more complexity of problems. So they will try to use both of these at the same time. So this is probably a 5G use case scenario that can be used to imagine in a particular society what we want a 5G use case place to be. So we can say network slicing, gigabits per network slicing we can see here, where the network slicing uses massive MIMO technology using beamform through beamforming, and it circulates the networks throughout the areas which can easily be contacted by other LTE providers. Then we can see self-driving cars. As we mentioned, that we are going to take in the use case of IoT technologies and such. So self-driving cars is going to be another one of the major technologies that are being used in this scenario. Gigabits in a second in major IT companies and industries, industry automation, and e-health, where e-health will be one of the major places where everything will be now specialized, from starting from receptionist to surgical equipment. Everything will be now automated. This means that there will be more accuracy of success for any, for example, let's say surgery. There will be more success of the surgery itself. Now, 3GPP release 15 and 16. Now we come to 3GPP. 3GPP can be said as a network director board for all the stuff standardization in the domain of telecommunication. So it will decide what are the basic packages approval, and release 16 how the basics rollout of certain technologies may happen. So since 2007 till 2022, there is a 3GPP section planned, as release 16 will be in 2020, which will be the approximate 5G drop. So this is like kind of an approximate a timeline that is being approved, where release 15 can be described as a non-standalone presentations where package approval is done. Release 15 is ASN1 late drop, and release 16 is the RAN freeze. So we will be getting into all of these package drops, ASN1s, and RAN freeze sessions later on in the session. Release 15 and 16 highlights. So what does release 15 and 16 say? So mostly it's about 5G new radio, or also abbreviated as NR. It is a new radio can be defined as radio access net part of a radio access network where 5G core cell is implemented. So the basically the highlights are ultra reliable low latency communication for mission critical services. For example, we have a service that requires high level of missions and critical services, so it has to be ultra reliable, and since it is a very important and high priority active service, so we need low latency communication, and it has to be extremely reliable. That will be provided by 5G. So that is mentioned in release 15 and 16. V2X type communication, vehicle to everything. This describes the general IoT connection where everything and everyone around us will be connected by through some sort of network. 5G NR integrated self backhaul focuses on small cell deployments. Self backhaul and small cell deployments refer to the base station networks and femtocells that are being deployed in particular scenarios, sometimes in a standalone manner or in a non-standalone manner. Study on non-orthogonal multiple access RSMA grant fee for IoT world. This will again be a boom in the IoT scenario, where non-orthogonal multiple access will be a certain network can include multiple access at the same time instead of being unary. 5G NR operations on unlicensed brand technologies and other radio access technologies. So this means that anybody who wants to apply 5G NR, it will be available for use in the public domain. It does not have to be necessary and specific in the use case scenario itself. Use of 5G for non-terrestrial networks, satellite, airborne, and maritime. And that is the release 15 and 16 use cases as mentioned by 3GPP. So as we look at the legacy network, so here we are going to take care of 2G, 3G, 4G, and 2.5G. So earlier there used to be a section called BSS. So BSS is basically a base station, which was basically the earliest level of internet data, and it used to provide uh, network using BTS and BSC cells. It used voice PSTN network. So this was basically called 2G, 2G in a cell. So what happened is 2.5G uses the base station network and uses data IP network. So BSC and data IP network together, when they are used in such cells, and that becomes my 2.5G. What is 3G is basically this base station network 2.5G on top of basic node V. What is node V? Node V is a type of cell that is connected to a user equipment, where the equipment can directly connect to the node V, and which is then connected to data IP network using that may or may not use EPC cell. Now, since that is the basics of 3G. Now 4G is basically an eNode B is connected to SGW in an EPC cell. What is an EPC cell? EPC cell is basically a cell that consists all of our LTE 4G network. So basically we keep hearing about this LTE. LTE is nothing but eNode B. It is another name for eNode B, which uses EPC cell, and that is connected to data IP network. We have also heard the terms of VoIP, voice over IP. So that these all are data network selections. As we come into 5G RAN, now we are entering into 5G RAN. Now 5G RAN has two types, standalone and non-standalone. Standalone is also abbreviated as SA and NSA. SA is basic, and let us explain NSA first. So NSA is combination of 5G and LTE within a single cell. Like we keep talking about like 5G. Application of 5G by itself is right now is a little bit cost expensive, is a little bit expensive and may not be cost effective in all use case scenarios, since a lot of people still use 4G to this day. Not everyone is converted to 5G, so also we need to keep the applications of 4G alive. So anything that is a combination of 4G, so let us say an EPC cell which is connected to LTE, and then a 5G NR radio is applied on top of it. Here we have the EPC cell and the new radio. No, sorry, this is the GNB cell and new radio, and then it is connected to LTE. So basically this is 5G on top of LTE, and this is LTE on top of 5G, but the cell will be able to demonstrate actions between both the classes. Now coming to SA is quite simple. Here is a G node B cell, and there is a plain 5G cell new radio. So these are the two types. Now these types have several options within them also. For standalone, we have option 1, 2 and 5. Option 1 is LTE directly connected with EPC. It has no 5G applications. Option 2 is new radio is directly connected to 5GC with GNB. It has no 4G. And option 5 is LTE connected with 5G core, and it has no new radios options. So here it is 4G. So 4G here, 4G here, and 5G here. So these are the three options, but these are individual. They do not have the combination, or they cannot support both 4G and 5G within the same cell. Now here we come to EPC core. Now we have LTE and new radio connected to an EPC cell. Again we have that is my option 3 for a non-standalone, and new radio and LTE connected to 5GC. And again LTE and new radio connected to 5GC. Here new radio is on top of LTE, and here LTE is on top of new radio. And since new radio is a direct 5GC component, a 5GC component has to be directly connected with new radio. So that is the specification that is required. And within option 3, as we saw here in option 3, with an option 3 may have specifics. For example, these are the various types of connections, control plane and user plane, that may be connected within option 3 itself. So here we have S1U channel, S1C channel, user plane channel and control plane channel here. And here this is connected to new radio, and then it is connected to LTE cell. Again, this is connected, but here LTE cell has a user plane channel directly to the EPC, since LTE can be connected to EPC by itself. And yeah, and here it is similarly as expected, and these two have a connection of control plane. Again, this has to have a connection of control plane, but there you user plane and control plane, but there is no such connection here between them, these two, of the user plane itself. User plane connection is directly between LTE cell and EPC cell. Now, as we move into non-standalone connections, these are the various options for option 4, option 4A, option 7A, and option 7. These are the four cells, which is similar in terms as we saw in option 3. This is again an example. Now we are talking about E node B and G node B. This is the description where the G node B has NR RLC and MAC layer, and E node B has PDCP RLC and MAC layer. This is the difference between the two. And in such scenarios, there can be various connected between RLCs and MAC in the secondary node split, which can be in any option within 3, where the PDCP layer can be directly connected to RLC and MAC layers. Now 5G RAN architecture. If we talk in the first versions, the option 3x to be used in NSA deployments. So anything that we see today 5G is based on this particular observation. So an EPC cell is connected to PDCP and through MGC bearer, and the EPC cell is connected to PDCP, NR PDCP, new radio PDCP 5G GNB using the NR SCG split bearer. And now these can be interacted where the PDCP is connected to the RLC and the MAC, and then it is then connected to the UE. And if it's a 5G call, then it can be directly processed through here and can be directly processed through the NR MAC layer. If it's a 4G, it has to come through here and then travel to the LTE ENB. But it entirely depends whether for example, the call is a 5G based on 4G or a 4G based on 5G. This is again an example of the previous. So SGNB and S1U, which is the user plane, is connected. The GNB is connected to the EPC using the S1U plane, and MENB is connected with the both S1U and S1C control planes. And then MENB and SGNB can be connected with the UE if required based on what the user wants. Now this is an L3 call where ME and SGNB connections are existing, and then they are connected to the UE's network directly. So this is the basis of a call, how it is processed. So first, initial UE message is sent from the MENB. For example, we want to make a 4G call. So initial UE is sent, then the location is gated and create session request. A session request is created by SGW, and the session request is sent to PGW, and the response is created, and then the response is sent back to MME. Now the MME returns an initial context request to MENB. Now once the context request is done, the response is sent back to the MME, and then it sends modify bearer request as mentioned here. Modify bearer request and response is sent back to PGW, and then it is sent back. Once this is done, the modify bearer request, as GNB sends addition request and response. Once RRC reconfiguration is done, then the person can do basic call, the L3 calls on over random access. Now the 5G cell detection is done here. Whether the call is 4G or 5G then it is done here. Then it is based on data forwarding. Now we are talking about 5G. Now in the difference, like non-standalone 3 NSA and standalone SA, this is a basic cell differentiation of both GNB or an SGNB and MENB. Here we have one ENB LTE core and one 5G core. Here we have both 5G cores together placed in one, and they are connected to the base. So this is a standalone where there is no LTE at all involved, and here it is on the basis of an LTE. A GNB node is placed on top of an LTE. So if we want to make a 5G call, first we have to cross through a LTE call and then make a 5G call. So for a standalone architecture, we have 5G core, AMF access and mobility management function. AMF access and mobility management functions are in within placed within the 5G core, and where the GNB control unit and the GNB radio unit are then connected. GNB DU is a distribution unit and a GNB DU is a controller unit. These are all specified in 3GPP sessions. And then these interfaces are called F1 interfaces. These take care of basic transmission channels that are specified in accordance to the radio unit in 3GPP. One GNB or a classical or cloud deployment can be defined through the CU and U. The NG interfaces NGC and NGU are specified in 3GPP in TS 38.410 to 414. UPF is user plane function where it defines how the user plane is able to interact with the GNB nodes. This is the entire interaction of the 5G core network, where we keep saying the 5G core network 5GC GNB. This is the actual line process, where the first is NSSF and then AUSF. The AMF first takes call and then it is sent to SMF, where the PCF policy control function and the session management function are the ones that hold the basic formality controls of they will check for the data transmission, and then they will pass on to the AF application function. Now application function is the somewhat, and once it responses for through N5, and then it will travel back to the UPF, and once the UPF confirms it through DN, which is data network operator services and internet access, the UPF user plane function will then forward it to GNB and UE, which are here. So this provides the entire internal connection through starting from the authentication to network slicing and the unifying data manager, which is UDM, and SMF and PCF. They will have the entire processing within this function itself. So basically the 5G core network is total based on NSF, NG, ENB, AMF and SNF basic NAS security handlers, and these all will be defining the basis of the entire policy throughout the session. So anything that we start from the beginning to the end is entirely handled by this entire structure here. And this contains the NGRAN and the 5GC core basics. Once the internet connected can be done through UPF, PDU handling and mobility anchoring, and the GNB controls all of these services. For example, intercell RRM, RB control, connection mobility continuation, radio admission control, also control header, also known as RACH, measurement configuration and provision, dynamic resource allocation, also known as scheduler. SMF has UE IP address allocation and PDU session controls, which are then provided in the basis of certain NAS security or idle state mobility handling provisions as based on AMF. So with this, we can say this is the architecture of the basic 5G core cell. So I think thank you for coming to my presentation. I think that's the end of the session. Thank you very much for listening to my presentation. Have a great day.